Now we will discuss about hydrogen spectrum. See what I told, when the electrons gains energy, then that electron jumps from first orbit to second orbit, or first orbit to third, first orbit to fourth, first orbit to fifth. Like that, it jumps from first orbit to any orbit. Again, that electron jumps from higher orbit to its original position, nothing but its first orbit, because when the electron jumps from higher orbit to lower orbit, then only that electron gets stability. See, when the electron jumps from higher orbit to first orbit, then that series is called Lyman series. When the electron jumps from higher orbit to second orbit, that series is called Balmer series, Balmer, Balmer series. When the electron jumps from higher orbit to third orbit, that is called Paschen series. When the electron jumps from higher orbit to fourth orbit, that is called Brackett series. When the electron jumps from higher orbit to fifth orbit, that is called Fund series, PFUND. That means in hydrogen spectrum, that contains 5 series: Lyman, Balmer, Paschen, Brackett, Fund. What is Lyman series? When the electron jumps from higher orbit to first orbit, that is called Lyman. When the electron jumps from higher orbit to second, that is called Balmer. When the electron jumps from higher to third, that is called Paschen. When the electrons jumps from higher to fourth, that is called Brackett series. When the electrons jumps from higher to fifth orbit, that is called Fund series. Here there are some more points. In Lyman series, here we have to discuss 2 points: N1 and N2. N1, N2. N1 equal to nothing but lower energy level. Lower energy level. N2 nothing but higher energy level. So for each series we have to discuss N1, N2 values. In Lyman series, N1 is always 1 because that will be lower. But N2 may be either 2, 3, 4, 5, 6, 7. So in case of Lyman series, what is the definition? The electron jumps from higher energy level to first energy level, that is called Lyman series. Here N1 value is 1 and N2 value is 2 or 3, 4, 5, like that. Here one more important point is that is this Lyman series is present in UV region. UV region nothing but ultraviolet region. How can we say that? Actually, experimentally, for this UV region, experimentally they are having some wavelength and they are having some energy experimentally. But when the electrons jumps from higher level to first level, when we find their wavelengths or energy, then those wavelengths or energy will equal to UV rays, wavelength or UV rays energy. That is why this Lyman series is present in UV region. That is the meaning of that point. Next series, Balmer series. When the electrons jumps from higher energy to second energy level, that is called Balmer series. We discussed already. This is present in visible region. Why? Visible region means the rays which are visible to naked eye, that is called visible region, or visible rays. In that case, N1 value is 2 and N2 value is 3, 4, 5. See, when you see the diagram, then you get some idea. This is second level, nothing but Balmer series. For all Balmer series, N1 value is 2 and N2 value either 3, 4, 5, 6, 7, 8, anything. That is about Balmer series. Why this Balmer series is present in visible region? What I told you already. Experimentally, they are having some wavelength and energy values regarding visible region. When electrons jumps from higher level to second level, if you find its energy or wavelength, then that energy or wavelength is almost equal to that region. That is why that is present in visible region. Next, Passion series. Passion series means the electrons jumps from higher energy level to third energy level. That is called passion series. This is present in near infrared ray region. That means near IR region. IR means infrared region. Near IR means it is almost equal to near IR rays. That means when we find the wavelength or energy of this spectral lines, then that wavelength or energy of the spectrum is almost equal to IR rays. That is why it is present in near IR region. For this N1 value is 3. Why? Because this is present in third. And N2 value is either 4, 5, 6, 7, anything. Next, fourth one, bracket series. Bracket series means when the electron jumps from higher energy level to fourth energy level, that is called bracket series. It is present in middle IR region. Middle IR region means when we find the energy or wavelength of those spectral lines, that value is equal to middle of the IR region. That means suppose IR region value, suppose 100 to 250, suppose angstroms, 100 to 250 angstroms. This is IR, suppose we are assuming like that. Then if you find the wavelength of the bracket series, its value is 150 angstroms. That means this value is lies between 100 to 250. That means it is almost middle of the region. That is why this bracket series is present in middle IR region. So what is the definition of bracket series? When the electrons jumps from higher to fourth, that is called bracket series. It is present in middle IR region, where N1 value is so much, N1 value is 4, and N2 value 5, 6, 7, 8, anything. Next, and last one, that is what? Fund series. Here the definition is when the electrons jumps from higher energy level to fifth energy level, that is called fund series. It is present in far IR. So this is all about hydrogen spectrum. This is very simple. First here you have to know how hydrogen spectrum will form. When the electron, hydrogen gas is taken in discharge tube. When we heat that discharge tube, then hydrogen gas undergo dissociation. That means hydrogen molecules undergo dissociation. Then hydrogen atoms will form. Then the electrons present in hydrogen atom jumps from lower energy level to higher energy level by gaining heat. But at a higher energy level, the stability of the electrons will be less. So in order to gain the stability, those electrons jumps from higher energy level to again first energy level. In that process, the electrons releases energy in the form of radiations. When we pass those radiations in the spectrum, then we get spectral lines. Those spectral lines are like this. Here those spectral lines are categorized as Lyman, Balmer, Paschen, bracket, Fund. What is the Lyman? When electrons jumps from higher to first, that is Lyman. When electron jumps from higher to second, that is Balmer. When electron jumps from higher to third, that is Paschen. When electron jumps from higher to fourth, that is bracket. When electron jumps from higher to fifth, that is Fund. Next, drawbacks of Bose atomic model. There are few drawbacks. First drawback, this theory could not explain species contain more than one electron. Hydrogen contain one electron. That means that Bose theory explains successfully hydrogen spectrum. What is the meaning of this one? This theory couldn't explain more than one electron. If species contain 2 or 3 electrons, then this theory will not be applicable. That is the meaning of that point. Next, this theory could not explain Zeeman effect and Stark effect. What is Zeeman effect? The splitting of spectral lines in the presence of magnetic field, that is called Zeeman effect. That means when we apply magnetic field, those spectral lines undergo splitted. That is called Zeeman effect. When we apply electric field, then also the spectral lines will undergo splitted. That is called Stark effect. That means this theory couldn't explain Zeeman and Stark effect. Next, this theory could not explain the formation of molecules by the atoms. That means when the atoms combine, automatically molecules will form. So this theory could not explain that point. So these are the drawbacks of Bohr's theory. So this is all about Bohr's atomic model, hydrogen spectrum, and its drawbacks. In next video we will discuss about formula. Some formulas are there: radius of the nth orbit, energy of the nth orbit, wavelength, energy. We will discuss those formulas in next video. Thank you.